Now we're gonna take more exercises on Theorem 4 and its corollary. In Theorem 4 we have the limit of a fractional function where limit as x tends to a of. Up we have x to the power of n minus a to the power of n over x minus a. This is equal to the exponent of the terms of the numerator n times a to the power of n minus 1 for each n belongs to r minus 0. The corollary, we have limit as x tends to a of a fractional function in this form. In the numerator we have x to the power n minus a to the power n over x to the power m minus a to the power of m, and this is equal to n over m times a to the power n minus m for each n and m belong to r except 0. Let's go to more exercises. Let's start by this one. Want to find the limit of first root. This is the first root of x plus 15 minus 2 over x minus 1 as x tends to 1. For the first term of the numerator, we have first root of x plus 15. First root of x, this means x to the power 1 over 4. And if we have square root of x, this means x to the power 1 over 2. We change this index or this first root into a power, so this means we have limit of, we can simply change it into x plus 15 to the power of, put the index is 4, so put it in the denominator of the power, minus 2. Now the numerator is unchangeable. It's not easy to simplify it or change it. So we have to change the denominator according to the numerator. The first term should be the same. So the first term of the numerator is x plus 15. So the first term of the denominator should be also x plus 15. X, just change it into x plus 15 by adding 15 and subtract 15. So plus 15 and minus 15, and still down we have 1. So minus 1 as x tends to 1. Also this we need to change it into x plus 15. So just add 15 to both sides. So x plus 15 tends to 1 plus 15. So 1 plus 15. So this is equal to limit as x plus 15 tends to 1 plus 15 to be 16 of. Now the first term is x plus 15 to the power 1 over 4 and minus 2. And down we have x plus 15 to be the first term minus negative 15 and negative 1 to be 16. Now a is equal to 16. What about this? The power of the numerator is supposed to be 1 over 4. So this is, the 2 is supposed to be something to the power 1 over 4. So if a is supposed to be 16, so let's try 16 to the power 1 over 4. Yes, this is equal to 2. So this is equal, the 2 can be written as 16 to the power 1 over 4. So let's rewrite this. So limit as x plus 15 tends to 16 of. Here we have the first term is x plus 15 as it is to the power 1 over 4 minus 2 can be written as 16 to the power 1 over 4. Down we have x plus 15 and minus 16. Now a is 16. N, the power of the numerator, is 1 over 4, and down there is no power, or the power is 1, so we will use the theorem. And this is, by the theorem, this is equal to, the limit is equal to n, or n is 1 over 4, times a, which is 16, to the power n minus 1, or 1 over 4 minus 1. 1 over 4 minus 1 to be 3 over 4, so 1 over 4 times 16 to the power negative 3 over 4 times 1 over we can simply change this into the fourth root of 16 to the power of 3, or we can put the 3 outside, so this is equal to 1 over 4 times fourth root of 16 is 2, so to be 2 to the power 3 or 8, so this is equal to 1 over 4 times 8 to be 32. Now let's take this. We want to find the limit as x tends to 1 of x minus 1 over cubic root of 26 plus x minus 3. Look at this. It's not easy to simplify or change this term. So we will keep this and we will change the numerator as the first term of the numerator, and we will change this. Let's see how to do this. First we have cubic root. Down we have cubic root of. And cubic root means something to the power 1 over 3. So put the index down. So let's write the function. We need to find the limit as x tends to 1 of. Let me start by the denominator. First, cubic root of 26 plus x means, let me keep it as 20. Let's rewrite it as 26 plus x to the power. If this is cubic root, so the index is 3, so it has an exponent, a fractional exponent, where the denominator is 3, and of course the numerator is 1, minus 3. Keep it as it is. Now we will not change this, but we have only x up. We need to change it into 26 plus x. So simply by adding 26 and subtracting 26, don't forget we have minus 1. The same thing, we will do the same thing for this part. We need also to change this. So we need to change x into 26 plus x. So just add 26 to both sides, and now let's simplify. This is equal to limit of 26 plus x as x when it tends to 1 plus 26 to be 27 of. For the first term of the numerator, keep it 26 plus x. Now it matches the first term of the denominator, so 26 plus x, and minus 26 and minus 1 to be negative 27. Down, the first term is the same, 26 plus x to the power 1 over 3 and minus 3. What about a? Here we have 27. So a is supposed to be 27. Yes, this is okay. For the denominator, we need to change the 3 to match the same a. We need a power for the denominator to be 1 over 3, and we need a to be 27. So 27 to the power 1 over 3 is equal to 3. Yes, this is the cubic root of 27, so this is equal to 3. So we can rewrite the 3 as cubic root of 27, or 27 to the power 1 over 3. So this is equal to limit as, by the corollary, this is equal to, take the power of the numerator over the power of the denominator times a to the power n minus m. So this is equal to, power of the numerator is nothing, so 1 over power of the denominator is 1/3 times a, which is 27 to the power of power of the numerator, so 1 minus power of the denominator, which is 1/3. This is equal to, if you have a number down, if you have a denominator of the denominator, just move it up. So just move the 3 up. And here we have 27 to the power 1 minus 1/3 to be 2/3. 2/3 mean, power of 2/3 means, so 3 times, if you have 3 in the denominator of the power, this means cubic root. Just change it into a cubic root and keep the square power. You can just keep it outside or put it inside. And down we have, inside we have 27. Cubic root of 27 is 3, and we have a square power, so 3 times 3 squared to be 9 times 3 to be 27. Now take another one. Now I want to find the limit as x tends to 1 of x to the power 12 minus 1 over x cubed minus x squared plus 3 minus 1. We need to make a certain change, of course. Okay. Think of, in the numerator, we have two terms. We have x to the power 12 and 1. 1 can be raised to the power of 12, so no problem with the numerator. But the denominator, we have 4 terms. This is not easy to factorize. So think of factorizing by grouping or factorization by grouping for the denominator. So limit as x tends to 1 of, keep the numerator as it is, x to the power 12 minus 1, put power 12 for the 1 to match the theorem or the corollary. And now let's try to factorize it by grouping. For the first two terms, let's take x squared, take it out as a common factor for the first two terms, and divide each term by x squared to be x cubed divided by x squared, subtract 3 minus 2 to be x, and here x squared over x squared to be 1, then plus x minus 1. So we have here another common factor, so x minus 1 can be taken out as a common factor, so this is equal to limit as x tends to 1 of, keep the numerator as it is, and down take out x minus 1 as a common factor, and here we have, now cancel x minus 1 from each term, so here we have x squared, and here we have plus 1. So what we're going to do is to separate this part. So this is equal to limit of as x tends to 1. The first part is this. So x to the power 12 minus 1 to the power 12 over x minus 1. This is the first part. The second part is this. We will separate it as by multiplication, of course. So times limit of, we will separate it as a fraction. So 1 over x squared plus 1, of course, as x tends to 1. And the first part, we can do it by the theorem. In the second part, we will evaluate it by direct substitution. So this is equal to, by the theorem, this is equal to, so x to the power 12 minus 1 to the power 12 or x minus 1. So this is equal to n times a to the power n minus 1, or n is 12 times a, which is 1, to the power 12 minus 1 to be 11, and times this part, we will evaluate it by direct substitution. So put x equal to 1, so 1 over 1 squared to be 1 plus 1, so 1 squared is 1, not 2, of course, so 1 and 1 to be 2, so this is equal to 12 times 1 to the power 11 is 1, so 12 times 1 to be 12 times 1 over 1 squared plus 1 to be 1 over 2, so 12 over 2 to be 6.